A visitor from outside our solar system just flew past the sun, and it might be older than the sun itself. Not older by a little, possibly billions of years older. Scientists pointed the James Webb Space Telescope at it, and what came back changed how we think about objects from other star systems. Stay with me, because this is one of the strangest confirmed space stories of the last year. I'm Arif Hassan, and this is History. If you want real data instead of wild guesses, follow now, because we're getting into exactly what NASA confirmed. Our solar system has one sun, 8 planets, and countless smaller objects, all bound by the sun's gravity, looping around forever. Every once in a while, though, something shows up that doesn't belong here at all, something that formed around a different star entirely and is only passing through once before leaving forever. These are called interstellar objects, and in all of recorded human history, we've only confirmed 3 of them. The first arrived in 2017, small, oddly shaped, and strangely quiet, showing almost no visible gas or dust, which made it maddeningly hard to study before it faded from view. The second arrived in 2019, and behaved much more like a familiar comet, with a visible tail, giving scientists a richer look at its chemistry, though it too was gone before long. Both encounters left researchers hungry for a third opportunity, something bigger, brighter, and active enough for the world's best instruments to get a proper look, ideally with enough advance warning to actually plan for it. That's exactly what happened next. On July 1st, 2025, a survey station in Rio Hurtado, Chile, part of a network called the Asteroid Terrestrial Impact Last Alert System, flagged a fast-moving point of light. Within days, astronomers confirmed it. This object was moving far too fast to ever be captured by the sun's gravity. It would pass through once and keep going, never to return. It became the third confirmed interstellar object in human history, named 3I/Atlas. Right away, something stood out. Its path around the sun was the most sharply bent, most extreme hyperbolic path ever measured for an interstellar visitor, moving at over 200,000 kilometers per hour when discovered, and accelerating as it fell toward the sun. Here's where it gets genuinely shocking. Based on its speed relative to the average motion of stars in our part of the galaxy, scientists estimated it has been drifting through space for somewhere between 3 billion and 11 billion years. Our own sun and solar system are about 4.5 billion years old. That means this comet could be older than the sun itself, possibly formed around a star that lived and died before ours ever ignited, then drifted alone through the galaxy untouched until it happened to cross our path. Unlike the quiet first visitor, 3IATLAS turned out to be genuinely active. As it approached the sun, frozen material on its surface began turning directly to gas, forming a glowing coma and a faint tail, releasing its internal chemistry into space, where telescopes could finally analyze it. Because the detection came early, astronomers had months of advance warning, something they never had before, letting space agencies schedule time on the world's most in-demand telescopes, well ahead of its closest approach. This is where NASA's James Webb Space Telescope comes in. Webb doesn't see light the way our eyes do. It's tuned to infrared, letting it pick up heat signatures and chemical fingerprints invisible to ordinary telescopes. Engineers locked Webb onto the fast-moving comet in August 2025, capturing its first detailed chemical spectrum. Then, in mid and late December 2025, after the comet swung around the sun, Webb observed it again, with an instrument tuned to mid-infrared wavelengths, capturing the most detailed chemical readout ever taken of an interstellar object. What came back surprised scientists. The comet showed an unusually high amount of carbon dioxide relative to water vapor, breaking the pattern typical of comets that formed in our own solar system. Then came the bigger discovery. Deep in that mid-infrared data, Webb detected the clear signature of methane gas, the first time methane has ever been directly detected coming from an interstellar object, confirmed by NASA and the European Space Agency, and published in the Astrophysical Journal Letters. Alongside the methane and carbon dioxide, Webb also picked up water vapor and a distinct atomic signature belonging to nickel. Methane is a fragile, lightweight molecule that breaks down under the raw cosmic radiation an object drifting through interstellar space for billions of years would constantly face. Scientists hadn't necessarily expected to find much of it left on the surface of something this ancient. Researchers now believe Webb was detecting methane escaping from deeper, unprocessed material beneath the surface. Material shielded from radiation for billions of years, and only now exposed as the comet's outer layers boiled away in our sun's heat. In other words, Webb wasn't just looking at this object's surface, it was reading chemistry that had been locked away since before our own solar system existed. Webb wasn't alone. NASA's Hubble Space Telescope observed 3/ATLAS both shortly after discovery and again after its solar pass, eventually helping pin down its solid nucleus at roughly 2.5 kilometers across, noticeably larger than either of the two interstellar objects before it. That size is part of why this comet became so much brighter and easier to study than its predecessors. A space telescope called SPHEREx and ground-based radio arrays using ALMA observations added still more detail, detecting molecules including methanol and hydrogen cyanide. Because of how extreme and unusual this object was, some corners of the internet speculated it might not be natural at all. Scientists took that seriously and checked, pointing radio telescope arrays designed to search for artificial signals, called technosignatures, directly at the comet. The result was clear. No artificial signals were detected. Every instrument, from Webb's chemistry to Hubble's imaging to the radio searches, points to exactly what an ancient, natural comet should look like. The truth here doesn't need embellishment. A confirmed, possibly older than the sun visitor from another solar system, its chemistry read directly by our most advanced telescopes, is already one of the most remarkable natural discoveries of the decade. Here's why this matters beyond one comet. Every interstellar object we study gives scientists a direct sample of material formed around a star system we'll likely never see up close otherwise. We've had only 3 chances like this in recorded history, and 3I/Atlas delivered by far the richest dataset, thanks to its size, its activity, and the sheer instrumentation now available compared to 2017. The fact that we've confirmed 3 of these in under a decade, with detection technology still improving, suggests these ancient wanderers may be far more common than anyone guessed, and newer sky survey telescopes coming online are expected to catch them more often going forward. Think about the odds. This object formed billions of years ago around a star that may no longer exist, got flung into the emptiness between stars, and drifted for possibly billions of years, with no light and no warmth, until it happened to pass close enough during the exact narrow window of human history when we had both the knowledge to recognize it and the technology to study it, for our telescopes to catch it before it heads back into the dark, likely never to be seen again. That's the real story, confirmed by NASA, backed by data from Webb, Hubble, SPHEREx, and ground-based observatories working together across the globe. Follow now if you haven't already. Drop a comment telling me what part of this surprised you the most, and share this with someone who'd find it as fascinating as you clearly do.